Alrighty then, day 3 of 3.4. This one's actually a very, very short one. I probably could have thrown it on the last video. That's all right. Again, our objective is to use derivatives to analyze straight line motion and solve other problems involving rates of change. One of the things to point out is sensitivity to change. When a small change in x produces a large change in the value of a function f of x, we say that the function is relatively sensitive to changes in x. The derivative f prime of x is a measure of this sensitivity. So even companies will use derivatives. So there it is. In economics, economists have a specialized vocabulary for rates of change in derivatives. They call them marginals. In a manufacturing operation, the cost of production, C of x, is a function of x, the number of units produced. The marginal cost of production is the rate of change of cost with respect to the level of production. So it is dc dx. Sometimes the marginal cost of production is loosely defined to be the extra cost of producing one more unit. So on this one here, a couple of examples we're going to run through. Suppose that the dollar cost of producing X number of washing machines is C of X equals 2,000 plus 100X minus 0.1X squared. Find the marginal cost of producing 100 washing machines. So marginal cost, whenever you see marginal cost, you need to realize that they are going to be asking you for a derivative because they're looking for how much will the cost change, really. So we want C prime of x, which is going to be, the 2,000 drops away, we're left with 100 minus 0.2x. But they're asking us about 100 washing machines. So C prime at 100 would be 100 minus 0.2 times 100, which gives us 100 minus 20. So C prime of 100 would be $80. This is a cost, so we know it's $80. And really what it's saying is that, okay, this is how much, the cost of making 100 washing machines. To make one more washing machine, so that 101st washing machine is going to cost $80 more to make. And this is where it comes to that. We have supply and demand, and you also have this cost going because companies aren't in there to make the money. So they're looking at how much more will it cost me to make one more. And if it doesn't cost very much, then they'll go, oh, let's make one more. But as soon as that starts changing, they're going to start looking at the fact that they may be losing money because they're making too many, because now the supplies is costing more to get more supplies or whatever. Or maybe, the workers are now having to work longer hours, so now they're having to pay workers more. So, that's kind of things that they'll have to look at. This 2,000, now here's your economics lesson, this 2,000 would be a constant cost, no matter what. And that's why in the derivative it disappears. This would be, the rent on the factory, the electric bill, the phone bill, things that have really nothing to do with the production. It's just that these are overhead costs that they have to pay, whether they make one or they make a million. So then we look at things that are actually affected by the washing machine. Okay, and that is that on that one. So let's try another one. Suppose it costs C of x cubed minus 6x squared plus 15x dollars to produce X number of radiators when you're making 8 to 10 radiators are being produced. And that your revenue function is this. Gives the dollar revenue from selling those radiators. Your shop currently produces 10 radiators a day. Find the marginal cost and the marginal revenue. Okay, so C prime of x is going to be 3x squared minus 12x plus 15. Now this is just our function, and then R prime of x would be 3x squared minus 6x plus 12. But we want C prime at 10 because currently they're making 10. So C prime at 10 gives us 3 times 10 squared minus 12 times 10 plus 15. That gives us 300, 10 squared, 100 times 3, minus 120 plus 15. We continue doing our math. 300 minus 120 is 180, plus 15 gives me 195. So if we really wanted to identify it, if we're making 10 radiators a day, to make one more radiator a day, it's going to cost us $195. That's what these companies would look at. This is how much more it would cost. Now, let's look at the revenue. How much revenue would we get off of that? So how much more revenue will we get off of it? So we want R prime at 10 as well. So this is 3 times 10 squared minus 6 times 10 plus 12. So we get 300 minus 60 plus 12. And that is going to give us 240 plus 12, or 252. Dollars. So this is worth it. Hey, it's going to cost us $195 to build an 11th one, but we're going to get revenue. Marginal revenue is going to be $252. So we can even look at our marginal profit. I know it doesn't ask for it, but it doesn't hurt to look. Our marginal profit would be our marginal revenue minus our marginal cost, which would be $252 minus $195, which gives it to us to be $57. There's our marginal revenue. So in the end, they're making still $57. Now, how much were they making if they only made 9? If they only made 8? Is it worth it? Are they making a lot more and making that 11? So these are kind of questions that have to be answered when a company is looking at expanding. Is how much more is it going to cost? And is the cost worth the revenue that you get in from it? Because if these numbers were flipped, yeah, definitely wouldn't be worth it, because they would be losing $57 every time they made one. All right, one more question, and then we're going to be done. Suppose the weekly revenue in dollars for selling X number of custom-made desks is R of X equals blah. Draw the graph of R. What values of X make sense in this problem? Okay, so the graph, I'm not going to do a perfect little graph on here, but your graph is going to do something in the form of, it's going to come up, and it's going to kind of flatten out like this. Now, obviously, if you make no desk, it's going to cost no money. Now, was this revenue? This was revenue, yeah. So if you make no desk, you're going to make no money. That's obvious. But, as you continue making desks, but notice that when you graph this thing does start to flatten out. So as we continue to make desks, I don't want to say you're going to lose money. You're just not going to be making money. So what values of X make sense in this problem? Basically, as long as X is greater than 0. Now, some people will go, well, you know what? After about 10 desks, I'm not making any more money. I'm making pennies. You're right. You don't want to make just pennies off of a desk. So you're going to stop making them. So they want you to find the marginal revenue when X desks are sold. So part B, this is part A, part B. So let me bring that equation down. R of X equals 2,000 times 1 minus 1 over X plus 1. Now, this is where I want to remind you guys that this 2,000 here is just a constant. Our value over here is being multiplied by 2,000, our function. So when I do the derivative, it'll also be multiplied by 2,000. So right now I know R prime of X is going to be 2,000 times something. Okay, so let's do our derivative. I'm going to change this guy to X plus 1 minus 1 over X plus 1. Why would I do that? That way I have a common denominator here. So to make this have the 1 have the same denominator, it's got to be x plus 1. X plus 1 minus 1, which is just going to give me x over x plus 1. And yes, if you try to reduce it, guess what happens? Anyway. Okay, quotient rule going on here. So remember that this is going to be u prime v minus v prime u over v squared. So u in this case is going to be x, u prime is 1. V is going to be x plus 1, and v prime is also 1. So u prime v is going to give me x plus 1 minus x all over x plus 1, that's my v value, squared. So in the end, I just have 1 over x plus 1 squared. So I can rewrite this as 2,000 over x plus 1 squared. Yes, or this is for those of you guys that don't like that. There. That was part B. And then part C, yes, this is just a bunch of little side work, guys. It's gotta be there. C. Use the function r prime of x to estimate the increase in revenue that will result from increasing your sales from 5 to 6. So you go, all right, cool. So I want r prime at 5. Because remember, this is just telling you how much the change will happen from going from one to the next. You don't do 5 and 6, you're just doing 5. Because the marginal revenue after 5 is going to be that value you get. So this is going to be 2,000 over 5 plus 1 squared, which is going to be 2,000 over 36. 5 plus 1 is 6. 6 squared is 36, which is going to give us approximately $55.56. Now keep in mind, this is the marginal revenue that they'll make off of it. So the change in revenue. So say that right now they make these things for whatever cost, and they're making $500 revenue on each one. You know, the money, so they sell it for $500 kind of thing. Then the marginal revenue, because what's happening is the cost is going down, and so they're going to make $55 more, is what's going to happen. And so companies will do this to find out at what point are they getting their maximum profit. And that is the goal, is that they're making the most amount of money that they can make. So that's that one there. And I believe that's the last bit of this video. Thank goodness, I know. Because I think all of them together was well over an hour. So again, good luck on these, and I'll see you in class.